Hi class. So what we're going to look at now are Newman projections. So I have a molecule drawn over here on the left. And what Newman projections do is they allow us to look down a bond. So we're actually going to look right down this bond here in green. All right, and what that means is we're going to look as if we're stacking the two carbons on top of each other. So the carbon here in blue and the carbon here in red. And so the way we represent that is, let me draw the one in the front first. So we're just going to draw that with a crosshair, and I'll draw it in blue. So we're just going to make our OH to the left, just like it is already on the other side. We'll have our carbon in the middle, and we're just going to represent that with a dot. Our hydrogen and our hydrogen. And let me color code these just so that we're all on the same page. Now, the way we do the red one is we represent that with a circle. Right? And now we'll put all the groups on there. So on top there's a CH3. So let's put our CH3 on top. There's a hydrogen to the right. So let's do the same thing. And then a hydrogen to the left. And so we can do the same thing. All right, so now if we take a step back, what we've done is if we're looking right down this green bond, we actually can't see the carbon in the back because they're stacked behind each other. So what we do to make it easier for us is we just draw a circle. All right? And so the circle tells us that the CH3 group is stacked behind it. And then these are the three groups coming off it. Same thing in the front is represented by this dot. The OH is coming out, hydrogen to the right, hydrogen to the bottom. All right, so now what we have done is seen what's the orientation to the groups coming off of these carbons. All right, and so remember, we have two choices. They can either be staggered, or they can either be staggered or they can be eclipsed. And so when you're eclipsed, remember they're going to be stacked on top of each other. So if you're looking at this picture, what do you guys think? Is it staggered or eclipsed? What you should have hopefully picked was staggered, right? These two are set apart. All right, let me take a second and just quickly draw what it would be if it was eclipsed. So if it's eclipsed, what you would see is this front group would rotate over to be right on top of the CH3, and then this hydrogen would rotate over, be right on the hydrogen, right on the other hydrogen. So let me draw that really quick. So let's start with the ones in the back. I can draw my circle. We're going to leave those exactly where they are, so I'll keep my CH3 on top, hydrogen down, hydrogen to the other side. Now my OH is going to rotate around. So I'll put my dot here. And even though it's directly stacked, a lot of times we'll write them right next to each other just so that we can actually see them. And so this is my eclipsed. And this is my staggered. Now, what's really important when we're looking at these is looking at how these relate to energy. If you think about, these are really spaced out, right? There's actually some spacing between these two. So that tends to mean that it's the biggest groups are spread apart, right? Sorry, not the biggest group. These are the two biggest groups. But the groups are all spread apart from each other, right? This one, they're all stacked. So this one tends to be higher in energy. So higher in energy. Now, this is probably actually the worst eclipsed. And the reason it's the worst eclipse is if you look at this, we actually have the two biggest groups. If you remember, hydrogens tend to be the smallest atom. So now if you have these biggest groups stacked on top of each other, you're going to get a really bad interaction. So this probably is the highest energy. So not only are eclipsed higher in energy than staggered, when you put the two biggest groups on top of each other, you tend to get the highest energy. Now, if we look at this one, they're staggered, so that's good, but these two are still next to each other. All right, and so if two things are next to each other that are the biggest groups, right? So these are our two biggest groups. It's good, but it's not great, right? And so what we want to do is see if we can draw the lowest energy structure. And so that one is going to be when we're going to keep the CH3 on top by two hydrogens. Now, we said that of the blue ones, we have hydrogen, hydrogen, oxygen. The oxygen is the biggest. So we want that at the bottom, and we'll put my two hydrogens here. So this is also staggered, but this one's going to be anti, and this is the lowest in energy. And it's the lowest in energy because we've put our two biggest groups, right? For the red, the biggest group between the methyl, hydrogen is the methyl. And so we've made them staggered, and we put the two biggest groups apart. This one over here is going to be our gouch. So I'll put a giant G for gouch. And we're still staggered, but we put the two bigger groups next to each other, right? And since we have these two biggest groups next to each other, it's gouch. If they're anti each other, so 180, that's the best. So that's the lowest in energy. All right, I hope this helps.